zeroth power, but what's x to the 0? Or anything to the 0th power? 1. And of course, 2 times 1 times 1 is just 2. So this is the final answer. What happens when you throw a constant into the derivative function? It dies. It gives you 0, right? Because 7 is equal to 7 times x to the 0. And when you follow the rule, you feed that to the derivative function, dx, he spits out 0 times 7 x to the minus 1. Okay? But 0 times anything is 0. Cool? What about this one here? 8x plus 2x to the minus 2. Is it minus? Because you bring the negative 1 out front, make this negative 1 times 2 is negative 2. X to the negative 1 minus 1 is negative 2. Okay? Switching up just a little bit, what's dy dt if y equals t to the 4th plus 6t?
4t cubed plus 6.
4t cubed plus 6. Okay? So what's the difference between d dx and d dt?
Variable.
Huh?
The variable?
The variable, right. So they're essentially the same function, but this guy eats x's and this guy eats t's. Okay? So this dt is telling you which variable you're going to differentiate with respect to. Okay? Yeah?
Oh, we're not supposed to simplify the negative 2x to negative 2x power?
You mean algebraically?
Like put in a fraction?
I mean, you could write it like this. It's fine.
But you don't mind if you see it out.
Yeah, personally, I like this better. But I guarantee that the book will have some written like this, and you'll need to turn it into that form. Just know that those two things are equal. Okay? That was the point of the review assignment on the first day, is just getting used to those algebraic equivalences. Okay? So now that we know what the derivative, how to take the derivative, right? Which we learned in 2.2, which is just 2 days ago. Would you say this is pretty easy?
Yeah.
Like how easy? On a scale from 1 to 10. 1 being easy, 10 being hard.
Well, there is such a one.
4? 1? That's good. So, that's great because this is half of calculus right here. It's just taking derivatives. Okay? So calculus is like the greatest idea man ever came up with, and it's only 2 big concepts. The first is how to take the derivative, or differentiate, and the second is integrate, which is like the inverse of taking the derivative. Okay?
Sure.
Does that make sense? It's the derivative run in the reverse. And that's all calculus is. Of course, these are really simple examples because what type of function are they? Starts with a P. Polynomial. Yeah. Okay. So what we study in this class are pretty much polynomials and then rational functions, which rational functions are ratios of polynomials, and then exponential functions. We don't study trig functions at all in this class. So polynomials are like the nicest, easiest examples you'll ever find because they're continuous everywhere. Okay? And they're really easy to take the derivative of because you just use this power rule on each individual term. Okay, so if you see a polynomial, you should smile because you already know how to take the derivative. Right? So next what we're going to do is we're going to look at products of polynomials and ratios of polynomials. So I'm going to skip to 2.4 first and I'll go back to 2.3, which is rates of change. Okay, so let's say that I have a product of a polynomial, like let's say f of x was x cubed plus 2x times x to the 5th plus 7. How would I find dy dx or df dx? Product rule? And what does product rule say?
It's the first times the derivative of the second plus second times the derivative of the first.
So you said it's, let's call this first, let's call that second. You're saying that df dx is going to be the derivative of the first, or you said the first times the derivative of the second, plus the second times the derivative of the first. Okay? Does it matter if I switch first and second in this expression? No, because you're adding them together. So if I were to say derivative of the first times the second plus the derivative of the second times the first, I'd get the exact same thing. Okay? So write this down. First times the derivative of the second plus the second times the derivative of the first. And this is called the product rule. The very original name I know. Why is the product rule?
Involves products of functions.
Yeah, it tells you how to differentiate products of polynomials. This is a polynomial, that's a polynomial, and it tells you how to differentiate the product. Bless you. Okay. So when I plug this formula in, well, this is the first. So the first is x cubed plus 2x. And I'm going to take the derivative of the second. So I need to take the derivative of x to the fifth plus 7. And I'm going to write down the second is x to the fifth plus 7. And I need to take the derivative of the first, which is x cubed plus 2x. Okay. And so I just rewrite this. X cubed plus 2x. What's the derivative of the first? It's the derivative of x to the fifth plus 7.
2x, 4x to the fourth.
Careful.
5x.
5x to the fourth. Because I'm bringing the power out and then subtracting 1 from the power. And then the derivative of 7 is just 0. What's the derivative of x cubed plus 2x?
Squared.
3x squared plus 2. Cool. And then, can you simplify this? Yeah, just distribute the 5x to the fourth into there, and then FOIL this, combine like terms. So let's just go through that one time so you see how it's done. So that'll give you 5x to the 7th plus 10x to the 5th. And when I FOIL that, I get first is 3x to the 7th. And then outside is 2x to the 5th. Inside is 21x squared. And last is 14. And now to combine like terms, I'm going to look for, well, I have 5x to the 7th plus a 3x to the 7th will give me 8x to the 7th. And then a 10x to the 5th, 2x to the 5th will give me 12x to the 5th. And then I have 121x squared and 114. Okay, so that's my derivative. df dx is equal to that. Yeah.
You can't multiply first and find the derivative after that?
No, you can. You'll get the same answer. If you FOILed this out, I mean, let's just do that real quick. If I were just to rewrite f of x as x to the 8th 7x cubed plus 2x to the 6th plus 14x. Then when I take the derivative using the good old power rule, I'll get 8x to the 7th plus 21x squared plus 12x to the 5th plus 14. Okay. So you can do either one of those easier. It's your choice. Sometimes some things are easier to take using the product rule. Because these are nice polynomials, it's really easy to FOIL this. But when we go into harder examples, like when we have square roots and stuff, sometimes it's hard to see how to FOIL it, or you can't FOIL it if it's like the square. If this was like the square root of x cubed plus 2x, and that was like the third root of x to the 5th plus 7, then FOILing becomes a lot harder, and it's a lot easier to use product rule. Okay, so you kind of want to know how to do both, but you will get the same answer if you just FOIL it out and then take the derivative. Okay, so that's product rule. And you know to apply that because it's the product of two polynomials that you're trying to take the derivative of. Now, perhaps the harder one is when you want to take the derivative of a function like this. Okay. What is this called?
Quotient.
It's a quotient, or it's a rational function because it's a ratio of polynomials. When are rational functions continuous?
Or everywhere except when the denominator is 0.
Yeah, everywhere except when x to the 4th plus 7 equals 0. Okay. So that's when you see a rational function, you should think, man, this is continuous everywhere except for where that guy is 0. Because when that's 0, you're dividing by 0, and how do you break something up into 0 pieces? Can't do it, right? Okay. So when you see a rational function or a quotient, you need to apply the quotient rule. And the quotient rule is really easy to remember. What you need to do is you need to write down this rhyme. Low, d high, minus high, d low, all over the square of the thing below. So in words, that's low d high, minus high d low, all over the square of the thing below. Does anybody in here rap? Yeah? So who wants to sing the rhyme? Low d high minus high d low all over the square of the thing below. You remember that? Yeah? It's not quite as good as Pop Goes Illegal, but low d high minus high d low all over the square of the thing below. Everyone say it to yourself one time. Quietly. Just whisper it to yourself. It's okay. You need to memorize this. This needs to go into your long-term memory. Okay, so this tells me that the g dx is going to be low. Well, low is the thing on the bottom. So x to the 4th plus 7 times the derivative of the high, which is the thing on top, which is x to the 3rd plus 2. And it's minus high d low. So now high is x to the 3rd plus 2. And I'm taking the derivative of x to the 4th plus 7. Because that's the low part, the denominator. And then I need to square the thing below, which is the x to the 4th plus 7. So that's the derivative before I've simplified. You see that? Low d high minus high d low all over the square of the thing below. Now does it matter if I get this switched up? What if I had high d low minus low d high all over the square of the thing below? Is that the same answer? No. Because if this was like, let's say that this whole thing was 3, and that was 1, then 3 minus 1 is 2, and I'd get 2 over 1 squared is 2, right? But if I switched it around and I had 1 minus 3 over 2, I would get minus 2, so I'd get the wrong answer. So it's really important that you know the rhyme, because that helps you keep the thing in order. It's always low d high minus high d low all over the square of the thing below. Okay? So that would be bad. So what do? I guess I rewrite everything over again. What's the derivative of x cubed plus 2? 3x squared. And then I have minus x to the third plus 2 times, what's the derivative of x to the fourth plus 7? 4x cubed. And I have x to the fourth plus 7, 20 squared. Can I keep going? Okay, what do I want to do?
Distribute.
Distribute. Okay. So, I think you can put it down here. So 3x squared times x to the fourth is 3x to the sixth. And then 3x squared times 7 is 21x squared. And then I'm going to subtract off 4x cubed times x cubed is going to be 4x to the sixth. And then 4x cubed times 2 is 8x cubed. And notice that I distributed this negative sign. So I have a negative there and a negative there. And then when I FOIL the bottom, I get x to the 8th plus 7x to the 4th plus 7x to the 4th is going to give me 14x to the 4th. And then 7 squared is 49. Okay. Can I simplify any more? Maybe combine some like terms. I have a 3x to the 6th there, and a negative 4x to the 6th there. That's about all I can do. So, sorry, I won't forget that. This will be minus x to the 6th, minus 8x cubed, and then plus 21 x squared all over x to the 8th, 14x to the 4th, plus 49. Okay, and that's my derivative. Totally simplified. Now, if you're working these problems and you get to right here, where you just applied the derivative and you haven't simplified algebraically, and you're confident that you can simplify this on your own, feel free to stop here during these type B assignments, okay? Just work through it, get to here, and then you say, okay, I've applied the derivative, I'm done. If you need practice working on your algebra, then go ahead and keep simplifying until you're done with this. Okay? Because on the test, it'll be a multiple choice test. It could be written like this, or it could be written like that. Some of them will probably be written like this because it's shorter, and then if I want to get tricky, I might throw something on there like that. We have to simplify a little bit further. Okay? Sound good?